Hello children, today I am going to learn how to represent root 5 on the number line. This is question number 3 of exercise 1.2. So number is root 5. So to represent root 5 on the number line, you check it. This is your root 5, and this root number containing root 5 you should try to write as 4 plus 1. So you write the number whatever under the root, write the number in the form of something plus 1. You should try to write it in that format. And one thing, after writing you must check that this larger number should be always perfect square. The larger number should be always perfect square, and the number should be written in the form of something 1 perfect square plus 1. So if you are getting the perfect square of the first part, then you can show the number, represent the number directly on the number line. And after breaking the number as a plus 1, if the larger number is not a perfect square, then you have to follow some extra steps that will come later on. First, as it is given the exercise, root 5. First, let's try this. So root 5 is given. I have written the root 5 as 4 plus 1, where first number is your perfect square. Then, as the first number is a perfect square, so this 4 you write as 2 square plus 1. And then these two numbers, this is 2 and this is 1. This 1 also you can write as 1 square. So these base numbers 2 and 1, these 2 will help you to get this root 5. So how to get it now? See, draw one number line. Both sides give arrow mark and make divisions, taking suppose 3 centimeters. Taking 3 centimeters, extend here. So somewhere put here 0. As root 5 is a positive number, so we need the positive part here, so we are taking less part in the negative side. And minus 1 put left hand side, and right hand side put here 1, put here 2, and put here 3. Now see, after writing root 5 in the plus 1 format, we are getting 4 plus 1. 4 is perfect square, so it can be written as 2 square plus 1. So this 2 and this 1. The first number, larger number is square, the base number is 2 here. Because 4 is the square of 2, that's why you think about 2. And take 2 from the origin, from the 0 here. Take 2 divisions up to here. The larger number base number, the base number of the larger perfect number, base will be we represent the divisions on the number line. So this larger number square is 2 square, so base number is 2, so 2 will represent the 2 divisions on the number line from starting from 0. So up to here it will come. Then after that, the 1, next number is 1. So where to represent 1? To represent 1, you have to draw perpendicular. For this one, you have to draw perpendicular at this point. So to construct perpendicular, you have to construct it. To construct a perpendicular, I will show it. Here. Putting the pointer at 2. Put a pointer at 2 and draw this arc. This arc is intersecting the number line at 2 points. Now expand your compass, you can expand it. And where you see the arc is intersecting the number line at 2 points, that for at these 2 points you have to put your pointer. Now choose this point and put a pointer here. You can expand this compass. Now on the upper side, draw one arc with the same radius. Bring the pointer here at this point where the arc intersecting the number line, and try to intersect the previous arc. So we have got this point here. Then join this point with these two, then you will get a perpendicular. So this is the perpendicular. Then this one, that means you have to choose 1 unit on this perpendicular. See here, for each divisions I am taking 3 units, 3 centimeters. Each division is the measure of 3 centimeters. That means here I am taking 1 unit equal to 3 centimeter. Each division is 1 unit like that, and each division represents 3 centimeters. So here 1 unit equal to 1 unit or 1 division equal to 3 centimeters. So here also for this one I have to make one perpendicular of 1 unit, that means of 3 centimeters. So you can measure the division. One division you can measure with the help of your compass. Okay, so this portion represents 1 division. So this division I'll cut here on this perpendicular. Here I have cut. So this is here. One unit, and lower portion represents 2 units from here to here, and this perpendicular I am taking only 1 unit from this point to this point. Now join this 0 with this point. So I have joined this. Now see, after joining this I am getting a right triangle. Here base is 2 units, perpendicular is 1 unit. So you can find the hypotenuse. This portion is the hypotenuse. You can name this as A, and here this point B, and this point you can take as 0, or you can give name O also. So this portion is a right triangle where base is 2 units, perpendicular 1 unit. Now with the help of the Pythagoras theorem, find here this hypotenuse, this portion, using Pythagoras, that is OA equal to O square equal to OB square plus AB square. OB square means here 2 square and 1 square. So 4 plus 1 equal to 5. Therefore O equal to root over 5. So this O is equal to root over 5. So I have got the number root over 5. Now how to, this length is root over 5. Now how to represent root over 5 on this number line? So to get a root over 5 on the number line, again put the pointer at this point 0, and then measure this root 5 with the help of your compass. Measure this. Okay, we have got this, and take this radius and draw one arc. See the arc intersecting the number line here. So this point will represent your root over 5. So hope you have understood. Now next I will give one more example. The extra question is root over 7. So how to represent this on the number line? Now, as earlier I told you, the root over number should break is something plus 1. So this is root over 7. This we have to break this number as something plus 1. That means 6 plus 1. And after doing that, after breaking, you must check the larger number must be a perfect square. But here 6 is not a perfect square. So we cannot do it directly on the number line. Then less than root 7. The number is 7. Now take the lower number of 7. That is your 6. Think about the natural numbers. The number is here under the root number is 7. So the natural number smaller than 7 is your 6. Next, here it is not possible. The next is root 6. Now try to break this. Try to break this. It is coming 5 plus 1. Still the first number is not a perfect square. So this is also rejected, these two rejected. Now after 6 then the smaller natural number is 5. Now try to break this as plus 1. The 5 I can write as 4 plus 1. Yes. Here you see the number is perfect square. So what you do? First you have to show root 5 on the number line. Then with the help of root 5 you have to show root 6 on the number line. Then after showing root 6, then you have to show root 7 on the number line. So yes, step by step you go up to root 7 from root 5. Because why I am choosing root 5? Because root 5 can be written as 4 plus 1 where the larger number is a perfect square. But for 7 and for 6 it is not possible. So now to reach here, to represent root 7 you have to go from root over 5. Now already we have represented root over 5 on the number line. Do that. Again take the draw the number line. Make the divisions of 3 centimeters. Place the scale. 3 centimeter take as 1 unit or 1 division. Now, so here you see on this number line, this is according to the procedure as explained earlier. I have shown the root 5 here on the number line. This is the root 5. So from root 5, after root 5 you have to get root 6. After root 6 then you have to get root 7. The root 5 we have got. Next we should get root 6. Now how to get root 6? So to get root 6, your next step is that at this point A, this is a right triangle, this is a right triangle and this is the hypotenuse. So always at the end of the hypotenuse you have to try to draw perpendicular. So at this point A, this is the end point of this hypotenuse. Draw the at this point draw the perpendicular with the help of compass. So at the end point of a line segment, how to construct perpendicular? I hope all of you know this. So draw one arc like this. Then from here, cut 2 times. then top also we cut here, and from here you cut it. So from here first you the arc intersecting the line segment one side, left hand side, and with the same radius bring the pointer here and make the first cut on the arc, and again from here it should be exact on the point, and then make the second cut here. We have to make two cuts on the arc, and these two are the intersecting points on the arc. From these two intersecting points, at one point you draw one arc on the upper side, and from the another cut you draw one more line, one more arc intersecting the previous arc. So this is the point, and now I have to construct the perpendicular. Construct a perpendicular here at the end point of the hypotenuse. Now as it is a perpendicular, again have to make the cut off one length of 1 unit, that means of 3 centimeter. So 3 centimeter, you can with the help of scale also you can mark 3 centimeter here. So it is 3 centimeter. So this from here, from the A point is here, you can name it here B. Then again join this So now this portion is a right triangle. This is your root 5 and this is your 1 unit. So this is a right triangle, this is the base, this is perpendicular, this is hypotenuse. Now using Pythagoras theorem find this hypotenuse OB, and when you calculate this will come here root 6. So we have got here root 6, root 5 already done. Next I have got root 6. Sorry. Then after root 6 we will get root 7. Now after root 6 getting here, this is a right triangle. For this right triangle, this is a hypotenuse root 6. Now again at the end point of this hypotenuse you have to construct one perpendicular. So you can move your copy, rotate according to your convenience, and at the end point of this hypotenuse OB you construct one perpendicular as it is done earlier. Make arc here and make two cuts from this point. This is one cut, and this will be your second cut, and on the upper side you make two intersecting arcs from these two cuts. This arc drawn from this point, and from this point you draw another arc intersecting the previous arc. We have got this point here. Now this point and this point you join, you will get one perpendicular, and then on that perpendicular again on that perpendicular make one division of 1 centimeter from this point B to one division of 3 centimeter. So this is the point, you can name this point as C. This is your 1 unit, and join these 2 points. After joining these 2 points, I have got one right triangle here, and this is the hypotenuse. So for this right triangle OBC, that this is your base, this is your perpendicular, base root 6 perpendicular 1. and this is OC is the hypotenuse. So when you apply the Pythagoras theorem to find the hypotenuse OC, the OC will come here √7. You can try by yourself. So I have got √7. Now how to get √7 on the number line? So do one thing, pointer you put here of the compass and pencil you adjust with this point. Yes, you have adjusted here, little bit more it will go. Okay, fine. So this I am adjusting this compass with this hypotenuse OC, which is √7. Now I'll draw one arc here. The arc must intersect the number line at some point. Where it is intersecting, that point will represent your √7. So this point is representing your, so this point is representing your √7. And if you want to represent √6 also on the number line, so you have to use this hypotenuse OB to represent √6 on the number line. Adjust your pointer here and pencil here and draw an arc. Where the arc intersects this number line, that point will be your √6. So in this way you can represent numbers having √ sign on the number line. This is a new and fresh topic for you. Hope you have understood, and thank you very much. Some extra questions I'll give, and you please try it and submit to me on my WhatsApp number. Thank you very much.